Hello and welcome to Groundhog Graphics. My name is Martin, and in today's episode, I would like to discuss coding a prime number generator in C. It's okay if you cannot program in C or are unfamiliar with C. Knowledge in any other programming language should be sufficient to understand the examples I'm going to show you today. So, what is a prime number? A prime number is a number that cannot be divided evenly by any other number but itself or 1. That is, it cannot be divided by any other number without leaving a remainder. If the number can be divided by another number without a remainder, then it is not prime. Let's take a look at some example prime numbers. Here are the first 10 prime numbers. Let's take number 5. If we attempt to divide 5 by the number 3 or 4 or 2, we will always end up with a remainder. Therefore, 5 is a prime number. If we look at the number 6, which isn't in this list because it's not prime, notice that number 6 can be evenly divided by both 2 and 3. Therefore, 6 is not a prime number. Now, let's take a look at some code. The name of this function is prime. The 1 in this example indicates that this is my first attempt. Yes, it's simple, and yes, it's slow, but it is thorough and leaves little room for miscalculation. The function begins by accepting a parameter which is of the type unsigned long. Unsigned long essentially means a very large non-negative integer or whole number. In fact, you could optimize this function by simply changing this data type to unsigned integer, assuming you knew you would not exceed that limit. The change in speed would be noticeable. In fact, inlining this function would also greatly improve its performance. But this is straying from the subject of this video. Let's move forward and examine our for loop, which iterates from 2 to 1 less than n. Inside the body of this loop, I am using the modulus operator, commonly known as mod in some other languages. This permits me to perform division and compare just the remainder without the integer or whole number of the quotient. If the remainder is 0, then that means the number has divided evenly and the number is not prime. So we will return false. No, the number you passed to this function is not prime. If the for loop goes all the way through to the end and exits normally, then we will return true, because in no circumstance was the number divisible by anything but itself and 1. Now it's time to take a look at the main body of the program. Well, we start off with a few defined variables. P is our prime counter. A is for counting the number of primes in our for loop. N primes is for storing the maximum number of primes we are interested in seeing. And KB for keyboard key impression. That way, if a key is hit, we will know. The for loop is checking our counter to ensure we have not exceeded n primes, and also checking to see if a keyboard key has been hit, which would prematurely interrupt our prime search. We have our if statement, checking the return result of is prime, and if it returns true, then it will print our prime, and if it returns false, it will do nothing. And then we have the letter P for our prime increment, and it will increment 1 time per iteration of our loop. Okay, well, I think it's time now to run this and see if it works. Alright, so let's go ahead and start off with 10 primes. Now, let's go ahead and compare these primes to the ones that we saw earlier on Google. Make sure that this is accurate. Yep, it looks accurate. So this is working. So now let's go ahead and do another test. Let's run this 2,000 times and see how long it takes. Okay, well, that took a little bit. That was 33.45 seconds. So now let's go ahead and look to see what we can do to improve the efficiency or speed of our code. So looking at this code, we can see that we are attempting to divide every single number up until one less than the number passed to this function. Well, obviously that's just more divisions than we need. If we were to divide those divisions in half, we could save quite a bit of time. I've already made a function that does that. Let's go take a look at my second attempt at the prime function. This is only a small modification from the original. I've added the variable maxDiv, short for max divisor. I assign the value of n to maxDiv and shift the bits to the right one place. Shifting the bits is a fast way to divide a number by 2. Then, in the for loop, we now only have to check divisors up to half of the value of n. This should offer a significant boost in speed. Let's try it out. Okay, so this time it only took 21.76 seconds. That's a considerable speed boost. Well, now let's go ahead and take a look at the third isPrime function I have written. So this function is very similar to isPrime2, with the exception that instead of dividing the parameter passed to this function by 2, instead we are getting the square root of it and we add 1. So think about this. Let's say you have 100 and the square root of 100 is 10. 10 times 10 is 100. So that means we would only have to do divisions up until 10. That's it. So our loop here will not have to loop very much. So this technically is supposed to work. Now, I found this routine online, and I have not actually tested it for accuracy, so we will get to that. But we will run it right now, and we'll see just how fast it is. And 2,000 primes. And we've got it down to 12.19 seconds. That's pretty good. So that is definitely our fastest routine, but we still need to see if it's accurate. I have changed microphones now, and I know this one sounds much better, but this mic doesn't have the noise canceling feature that my other mic does. Unfortunately, my recording environment is usually noisy, so my noise canceling mic is necessary most of the time. This is my accuracy test for all 3 functions. Now we will see if they are actually working properly.
You may pause the video and review the code if you feel it necessary, but honestly, it's not important to the subject, and in the spirit of brevity, I'm going to skip the explanation and just let you know that it does work. Okay, we are going to test 2000 primes again, but this time it will run the test 3 times, using all 3 isPrime methods, beginning with isPrime1, the slowest, then isPrime2, and finally isPrime3, the fastest one that uses square root. We will know when it changes functions by seeing the numbers start over again, and if an error occurs, then it will halt execution and inform us of the error. So let's begin. We have an error, and yes, I knew the error was there, only because I tested this before I started recording. Believe me, I was a bit shocked when it first happened. Apparently, isPrime2 has claimed the number 4 as being prime, which is not true. This is very much why I like the first function isPrime1, not because it's fast, but because it leaves little room for error. Let's go ahead and take a look at the error, since it will be helpful in having a deeper understanding of the methods we are using. The problem occurs right here when we set maxDiv to n shifted right 1 time, or in other words, divided by 2. When n is equal to 4, and we divide by 2, our for loop will never execute, because it only loops if a is less than maxDiv. Well, since maxDiv is 2, and a is also 2, it bypasses our loop completely, giving us a false prime positive. However, we can fix this by simply adding a 1 to maxDiv. Now, let's execute this again and see how it works. Now, a fully successful test of all 3 isPrime functions. But before I conclude this video, I'd like to show you one more potential error we could have had in isPrime3. The error just so happens to be identical to the error we just had in isPrime2. Let's take a quick look. Here we have maxDiv equaling our square root and adding 1. Well, let's see what happens when we remove the addition of 1. There we have it. Once again, the for loop did not execute, and 4 was reported as a false prime. So, make sure to add 1 in your own function if you use one of these methods. Well, this concludes this video on primes. I have to admit, I enjoyed making this video very much, and I do look forward to seeing you again soon. Take care and happy coding.